Okay, this is problem 2113, and the problem say like this. You have three charges. One charge, you put it here, Q3. The other charge, Q1, you put it in the middle. And Q2, you put it at the same distance than this, the double distance. So it's 2 centimeters and another 2 centimeters, so they are far away, 4 centimeters. So Q3, Q1, and Q2. So it say pay attention to the chart Q3, and imagine that you don't want the chart Q3 to move. You don't want the chart to be accelerated. So you want the chart Q3 to be with zero acceleration, means that the total force acting on Q3 should be zero. Of course, meanwhile this is happening, Q1 and Q2 must be in some way glued to the floor, or glue, because Q1 will accelerate also, and Q2 will accelerate somewhere. So it is supposed that the problem have fixed positions. Q1, Q2, and Q3. Q1 and Q2 are fixed position. They are sticky to the table. Q1 and Q2, they are sticky to the table, while Q3, they are free to move. They are free to move, but you don't want to be accelerated in any direction. You want that the force acting on Q3 will be zero. Acting on Q3, there is a force due to Q1, due to Q2. So the total force acting on Q3 will be the force acting on Q3 due to Q1, plus the vector force acting on Q3 due to Q2. So this problem is a challenging problem in the sense that it challenges you to find the vector, unitary vector R. It challenges you to find this vector. And let's go to see what happened. It challenges you to use this equation. The force acting on two is K by Q divided by the distance squared that separate, and it challenges you to see who is this vector exactly. Okay, let's go to see it. So the force acting on Q3 will be two terms, once due to Q1 and once due to Q2. The problem say that the charge Q3 is positive and the charge Q2 is negative, so between them they will have an interaction that will say to go to the right. So F of Q3 going to acting on Q3 due to Q2 will go to the right, while F on Q3 due to Q1 should be to the left if you want to have a total force zero. Okay, so the force acting on Q3 is the vector sum of these two expressions. So what will be F of Q3, F acting on Q3 due to Q1? K by Q3, no doubt, by Q1, but I know that I'm not touching here the values. The values, if Q3 is positive, I will plug in a positive value. Q1, it is clear that Q1 should be positive to create a repulsion in a way that the force due to Q1 will go to the left. Okay, it will go to the left if Q1 is positive. So the force acting on Q3 due to Q1 will be K, Q3 positive, Q1 positive, the distance that separates the square, perfect. Now the vector the vector unitary R with the cap, this vector will be the vector from the source to the point of observation. So it will be a unitary vector in this direction. So this is the vector, this one, minus I. So I should put here the vector minus I. So let's go to the other term. The other term is the force acting on Q3 due to Q2. If it's due to Q2, Q2 is the source. So the vector that going from Q2 to Q3 is going this direction. So again, it should be a minus I. So I will put K. The sign of Q3, I cannot touch it. The sign of Q2, I cannot touch it. I should plug in the sign of Q2. The distance that separates 3 to 2 square, and the sum for the forces should be 0. So the sum for the forces should be K by Q3 by Q1 divided by the distance between 3 and 1 square plus Q2 divided by the distance 3 to 2 square, and the vector will be in the minus I direction. But if I want this vector to be 0, 0 in the minus I direction, if I want to be the zeros, this should be 0. So Q1 plus Q2, Q1 divided by D31 square plus Q2 divided by D32 square should be 0. So Q1 divided by D31 square should be minus Q2 divided by D32 square. This means that Q2 should have opposite sign at Q1. So Q2 is already calculated. Q2, that is what it's asking us, is minus 5 minus, the minus is this minus, Q1 is plus 5 by 10 a la minus 9 by the distance square D32 square. It was, I don't remember, 2 centimeters. It was 2 centimeters by 2 by 10 a la minus 2 square divided by the distance between 3 or 4 by 10 a la minus 2 square. And in doing this, you will find plus 5. You will find the magnitude of Q2. You do it. Q2 equal, you do it. Okay, done. Well, there is another way to do it that, of course, it will not imply to know about what is the vector R. Is to find on Q3 to find this vector F of F acting on 3 due to 2, and now to find the magnitude of the vector F acting on 3 due to 1. And because these are the same thing, but you find the magnitude, you put it equal and you make the problem in the same way. But the real way to do it is like this.